In this video, we're going to discuss the equation of continuity. And the equation of continuity applies whenever you have a fluid flowing through one cross-sectional area of a pipe and it then flows into a different area or cross-sectional area of pipe. Now we're going to set up a scenario where you can see I've already labeled in here two volumes or two cylinders. So I've labeled an area because we're going to deal with the cross-sectional areas, and I've labeled the sides here, so given the height of these cylinders. And I, of course, haven't drawn these to scale, but we're setting it up so that the mass passing through cylinder 1 is equal to the mass passing through cylinder 2. And I'm going to replace that mass by subbing in the density equation. Now, whether these two sides are actually equal to each other because they're the exact same values, or because they're equal to each other because of one increasing and the other decreasing, depends upon a situation we'll discuss later on. Alright, so we can split volume into area, so our cross-sectional area, times the length of the side of the cylinder. So we split 3 dimensions into a 2 and a 1 dimension. So we still have the same number of dimensions. And we also can relate the side, so the dx here, by volume and time. So we can say that it takes a certain amount of time to pass through this particular cross-sectional area based upon the velocity. And the times in this case are going to be identical. Now, we can make one more cancellation if we make an assumption. If we assume that the fluid is not compressible, because as we move from this area of the pipe to this area of the pipe, we're going to find that there's a change in pressure, or change in the molecules are arranged. So if we assume the fluid is not compressible, so that it's very hard to get the molecules to move closer to each other, therefore not changing their volume and thus not changing the density, then we can cancel out the density on either side and say that area 1 times velocity 1 is equal to area 2 times velocity 2. So this gives us a ratio to explain how the speed of the fluid from this area to this area changes.